I'll introduce you to Dr. Priyabrata Bag. He's a faculty in our department of mathematics. Sir, so can you tell us what you work on? What exactly is your speciality?
My main research interest is quantum information theory, mostly from mathematical background.
Okay, so quantum information theory. So this sounds so futuristic and like from a sci-fi movie. Can you tell us more about it? Yeah.
It's the
Louder,
idea of
louder.
building a computer
Okay.
based on the principles of quantum mechanics. And
Okay.
theoretically, it's already shown that it has some advantages over the existing computer.
Okay, so you use quantum mechanics to build a computer. So how does it really is different from a normal computer which we use?
I think it would be a good idea to give a brief comparison between these two types of computers. In the usual computer which we have, if you want to represent any information in that computer, ideally it should be represented in terms of sequence of zeros and one,
Okay.
which are one could which think that as a sequence of zeros and ones. So maybe 0 0 0 a sequence, or 1 1 1 another sequence.
Okay.
And this can be interpreted very simply, like you have certain switches over there and you are putting it off or on.
Okay.
Accordingly, you are getting either a 0 or a 1.
Okay.
Parallelly, on the other side, if you think, the situation become like a system where certain quantum phenomena is available. For example, let's say an electron which has two different kinds of spin. One is called, let's say, up spin and down spin.
Yeah, if you could.
And in terms of mathematics, if you say up spin could be like a vector which is 1 0, and down spin could be taken as another vector which is 0 1.
Okay.
And due to Dirac's notation, one can even make it more interesting by putting a parallel notation for it. So let us call this one as Ket 0 and this one as Ket 1.
Okay.
This is due to Dirac notation.
Okay.
Now, apparently it looks like these two systems are comparable. Here also one had 0 and 1. There also similar 0 and 1 is available.
I see. I see.
But the beauty is, or the difference is, one would say, it's no longer only 0 or 1. It could be anything as a linear combination of 0 or 1, something like this.
Linear combination means it can be 0 and 1 both at the same time.
In some sense, yes.
Oh, that's cool. So I think that this 0 or 1, it looks like that you have just named it 0 and 1 means it is not like something absence of a signal or a presence of a signal. It is just a name 0 and 1.
Yeah, in terms of physical system, if you want, as I said, like it could be an electron which has two different spins. One of the spin is 0, other spin is 1.
Okay.
And in that case, this kind of linear combination can be interpreted as the position of the electron. It could be in half of up spin and half of down spin in some sense.
I see, I see. So the gist is the information is both 0 and 1 at the same time.
Both 0 and 1 at the same time. Obviously, one has to get a correct interpretation of that knowledge,
Okay.
which is usually done by the knowledge of probability. So
Okay.
when you say it's 0 and 1 with at the same time, it essentially means if you measure the system or observe the system from certain point of view, with certain probability we'll get to see a 0, and with certain other probability we'll get to see a 1.
So if it's a probability, then you have to use like thousands of those quantum bits to
Yes,
get.
well, number of bits anyway one would require for classical computer also.
Okay.
But the computation which one perform in classical computer, maybe one would do in one shot, whereas in quantum computer it's ideal to do in multiple shots and get a distribution of it, like probabilistic output of that particular computation.
Okay. So is there anything a quantum computer can do better than a classical computer which we use?
Well, there are already a lot of theoretical evidences
Uh-huh.
but actually implementing any of those algorithm in its full-fledged requires a lot of qubit.
Let's say that if anything in your knowledge, if you could tell us something which in theory a quantum computer can do better.
Yeah, so one very simple example which anyone would understand. Let's say you have any number, whole number,
Okay.
and someone wants its prime factors.
Okay.
If the number is very large, then the time to find the prime factors using the existing computer
Uh-huh.
will be huge.
Okay.
And one can obviously give like exact numerical numbers, and it has been observed that for certain numbers to find those prime factors it would take even like 8 years to 12 years.
Okay.
On the other hand, due to Shor's algorithm, if that can be implemented appropriately, then one could find these prime factors very easily, like in a very short span of time. If you say in the technical, if you use the technical words, then finding prime factors in classical computer is known to be an NP problem, whereas in case of quantum computer it becomes a polynomial.
Okay, so let's say that if it takes 8 years to factorize a number in classical computer, how much you think that it should take for a quantum computer, assuming proper implementation?
Well, it should be a few seconds.
Few seconds. So 8 years, and then versus a few seconds. I see. Okay, and so what are the reasons why we are not really able to implement quantum computers?
Well, as per my knowledge, currently there are two main limitations of quantum computer.
Okay.
One limitation is like it's very prone to errors, and one could understand it very easily. In case of classical computer, if there is an information which is, let's say, 0, and if anything wrong happen, it could become a 1. So only one chance, only one possibility of misplacing it or getting it an error.
Okay.
Whereas in case of quantum computer, if the actual information was 0, there are multiple options or multiple choices which could be an output due to error.
Okay, so it can be anything between 0 and 1.
Anything between like a superposition of 0 and 1 or linear combination of 0 and 1.
Okay.
So which makes it very vulnerable, like it's very difficult to gauge the actual input by looking into the output.
Okay. So in practice at present, are we using quantum computers somewhere? Means is there being utilized?
In a very limited setup, people are mostly it's in a laboratory setup. It's still not been commercialized.
Okay.
But there are certain techniques of correcting errors which are also there in classical computer. But as it seems like in case of quantum computer, correcting errors should be very costly.
Okay.
in the sense that one may have to use, to protect 1 qubit, one may need to use 1000 qubit.
Okay. So qubit means the quantum bits.
The quantum bits.
Okay.
Yes.
Okay. So you are working on quantum computation mathematical side.
Yes.
So are there other people working on the hardware side, the implementation side of this subject?
Yes, definitely. There are many laboratories who are trying for it, and I think many of the governments have already funded projects.
Okay.
To actually build a quantum computer. For example, in India also we are having something called National Quantum Mission.
Okay.
And they are trying to set up quantum hubs in different parts of the country. And the job of those hubs will be to build a computer, or at least parts of the computer at a time, and then combine it to a computer.
Okay, so what would you say something if you want to invite someone to this good field of quantum computation and information? What would you say to those young
If
people?
the person is from a mathematical background, I would say that there are a lot of mathematics, even though it sounds like physics. There are a lot of mathematics, including algebra, functional analysis, linear algebra. Most of the usual or the traditional mathematics, which are maybe so-called pure mathematics, one can get many of those tools to be used in this kind of.
Okay, so this is the fascinating, like scientific part of it.
Yes.
And now talking the practical side, what are the job prospects if someone say decides to pursue a career in quantum information? What would you say?
Well, according to the current trend, I would say that it's one of the very high topic to take up as a study or from the jobs prospect, whatever you call it, because there are, I would say, every day or every month, one new industry is forming who are trying to build a quantum computer.
Okay, okay, thank you. So this was Dr. Priyabrata Bag. He works in quantum computing, quantum information. He is faculty in GITAM University. Yeah, thanks for watching.